Hey CJ, math student, so I'm trying to help you out with this iReady lesson. So this question says, am I riding the bus home from school? The graph shows the distance in miles y, this side, that she has to travel after x minutes. So x is the input and y is the output. You input time, you get output distance. So it's a function if every input has only one output. So you see how there's only one dot as I go vertically on my line. This is called the vertical line test. So if you can only hit one spot in your data or on your line, then it is a function. So yes, it's a function.
Good.
But it is not linear.
The graph shows that for each input, or x value, there is only one output, or y value. The relationship is a function.
It's not
is the
linear.
Function linear or nonlinear?
Because you'll notice if I connect my dots, I don't get a straight line. So it's not linear.
Nonlinear.
So for this one, is this relationship a function? Every input, your x value input, has to have only one output, y value. So 0 only has 10, 1 only has 15, 2 only has 20, 3 only has 25, 4 only has 30. It is a function, right? If 1 had 15 and then there was another one and it had 20, then it would not be a function. So to complete the statement, the total weight, the output, is a function of all your inputs, the amount of granola that you put in, right? If you're graphing the data, you're just plotting points. At first, you're at 0, 10. Then you're at 1, 15. Make sure you go to 1 right here. 15 would be halfway between 10 and 20. Then you're going to 2 and up to 20. 3 up to 25. And then 4 up to 30. So if I connect these lines, I get a straight line. So therefore, that is linear. So if we're trying to figure out how much the total weight increases with each cup of granola, we're just taking a look at this and saying, all right, it's going from here to here. So it means it went up and then over. It went up 5 and over 1. This is confusing because like from here to here you would think was 1, but that's just a half. So from here to here is 1. So went up 5 and over 1. 5 over 1 gives you your answer of 5. So we have this constant rate of change because as we go up over 1, we go up 5. Over 1 full, we go up 5. Over 1 full, we go up 5. And that's why it's linear. It's got a constant rate of change. The slope of the line is just the same thing as the rate of change. It is 5. It's positive 5. It's going positive slope. So this asks us to say, hey, what's the weight of the jar when it's empty? So we start at 0. That would be empty, right? No cups. And we just go up and, oh, it's right there at 10. Right? So our answer here is 10 ounces when it is empty. That's our starting point, our initial value. The starting point, or where the graph hits the y-axis, as you can see, this is our y-axis right here. It's labeled y. Where the graph hits the y-axis is called the y-intercept. So the starting point when the jar is empty is the same thing as the y-intercept. It's 10. So the equation is you just take your slope, you plug it in next to x, so 5x, and your starting point, your y-intercept, you put it at the end. So your equation is always y equals your slope x plus your y-intercept, or y equals your slope and your y-intercept. So if we're trying to graph this equation, he starts at 0 at 2 miles. That's where that plus 2 comes in. And then we want to go down one full one, not just one square, but down one full and over 8. And this is 1, 2, 3, 4. That looks like 4, but this is actually 8 because each little line is worth 2, right? 2, 4, 6, 8. So you go down one full one over 8. You started at 2. This will tell you where to start. This tells you how to move. Down 1 and right 8. His starting point is 2, and Lorenzo starts, his starting point is 0, because that's where he finishes at 2 miles from the finish line. Messed up. Starts at 2. My bad. So those are the same thing, where he starts, where he finishes. The rate of change is negative 1/8 because that's what was in our equation here. We were going down 1 and over 8. And his distance to the finish line decreases. He's getting closer and closer by each minute. All right, so we're going to use the graph to complete these statements. When Ian starts tracking the vine's growth, where is it at? It starts at 4. So this should be 4. And the vine grows how much each day? So remember, this is kind of tricky because these graphs are not perfect here, but fill these in. So if I go over 1 day, I go up. It goes up 1 foot. If I go over 1, it goes up 1 foot. So it's just 1 over 1 the entire time. And so it should grow 1 foot each day. So as Naomi's climbing down, her temperature is going down as a result of the sea level decreasing. So the temperature is a function of the altitude. The initial value where she starts is going to be 56, and the temperature at that sea level is, sorry, the initial value, my fault, is 0, and the temperature at level 0 is 56. So as she increases her altitude, as she gets higher up, the temperature actually drops. That's why we have snow on the top of mountains, because it's super cold up there. So the rate of change here is she's going to start at 56, and then she's going to go down. Here's another point right here, right? So she goes down from 56 to 49. That's down 7. And then she goes over 2, right? And if you put in your calculator -7 divided by 2, you get -3.5. So as the altitude changes by 1,000 feet, your temperature decreases, right? Like it's going down, decreases by 3.5 degrees. And then within this problem, it says it's got a rate of change of 3 and an initial value of 2. So the drone starts at 2 feet, and the drone moves at 3 feet per second. So the only graph that matches this has got to be this one, because it starts at 2 feet, and it moves 3 feet per second. So you got to go up over up 3, which is 5, over 1. 3 over 1 is 3. And then lastly, the equation is going to be y equals your slope, which is 3, followed by x, plus your initial value, or your y-intercept, which is 2. So if we have an initial value of 4, we have to have 0, 4 to start. So that's these two top ones, and then it's got to change by 6. So plus 6, plus 6, plus 6. This one changes by 4, so it's got to be this one. So our initial value is wherever we're at 0, so 0, 2. And at the initial value, the head of the dragon is 2 feet long. And then the rate of change is just how does it change. It skip counts here in the y by 8. So each section of the body is 8 feet long. Lastly, our equation is just y equals our rate of change, which is 8, followed by x, aka our slope, plus our initial value, plus 2, aka our y-intercept.